All right, welcome everyone. Thanks for joining. I'm going to give it just a minute or so before we really dive in as people are jumping on. Hope everybody's enjoying summer so far, had a good 4th and all that business. I will give it 30 more seconds. Okay, let's go ahead and dive in. First of all, welcome. Thank you for joining us. We're going to cover today how to identify causes of equipment failure so that you can avoid them. I would like you to meet our speaker, Rick Boggs. Rick has served as Facilities Integrated Workplace Management Systems Analyst at CSU Monterey Bay and PM Coordinator at Monterey One Water before he joined Limbo in 2021, where he became the VP of Product. And today, what we're going to cover is strategies to effectively identify why your equipment is breaking down, the right maintenance strategy to help you cut down on those equipment failures, and how software can help you optimize equipment maintenance to reduce downtime. So Rick, I'll go ahead and pass it to you and we'll dive in.
Thank you very much, Katie. Hey, everybody. Thanks for joining us today. Today's goals, we're going to be looking at how to develop a repeatable process that you can identify why equipment is failing. So your equipment is failing frequently and you want to learn how to get a handle on it, or maybe it isn't failing terribly frequently, but when it does, it's lengthy, it's disruptive, or sometimes it's just a combination of all of them. But in any case, we need to have a repeatable process to identify why our equipment is failing. And once we have that, we can identify equipment failures, and then reduce the frequency of those failures by attacking the source. And the good news is we basically already know the 4 main reasons why equipment commonly fails. So let's take a look at those now. So the 4 main reasons for equipment breakdowns are just the standard regular wear and tear. Then we have a lack of preventative maintenance or no preventative maintenance, improper equipment usage by operators or any kind of operator error, and just having a poor or non-existent reliability culture. It goes hand in hand with basically not having any kind of preventive maintenance. So let's talk through each of these in a bit more detail. So for regular wear and tear, there are several factors that contribute to faster wear and tear on your equipment. So they can be poor operating and storage conditions. So if you have a high heat environment or an environment that has lots of dust, dirt, and debris, it can be really bad for the equipment. Same thing with vibration or anything like that. We can use, if you're using poor quality replacement parts, those parts can break down faster and their lifespan is much shorter, which can again result in additional breakdowns, and that asset's lifespan is just going to deteriorate more quickly as well. And fixing them might mean that, there's higher costs, right, for these higher quality parts, but sometimes they're just more expensive. And depending on the age and overall health of the asset, as well as the cost of the parts, you can decide if that cost or that more expensive part is actually justified. So really, this is what we're kind of going to get to when we get into identifying the causal factors of equipment breakdowns. And again, once the equipment just gets near the end of its lifespan, they're just going to break down more often. And not all equipment is actually meant to last forever, right? So as things age, they naturally break down. And if you're not doing any kind of root cause analysis, you may not be able to identify the cause of the failure is mostly due to its age. And so in the event of the asset is old and worn out, and repairing the asset isn't really always the best option. And eventually assets just need to be replaced, right? So your root cause analysis can help you identify that. And we'll get into that a little bit later. And lastly is just the lack of preventative maintenance. And we'll talk about that here in this next slide. So with the lack of preventative maintenance just leads to frequent and more frequent equipment failures. So the more your equipment breaks down, the more liable you will be to facing a growing, maintenance backlog. So the downtime of these equipment also results in a loss of productivity, maybe expensive replacement parts because you need to ship them out faster and you don't have critical spares on hand, additional staff overtime to make sure that your equipment gets back online to reduce any blockages to your production or effects to any of the additional staff members at your company. And so here's a basic example, right? So say the belt tension wasn't adjusted at the correct interval that it should have been. So a belt has worn out faster than expected, which has, just leads to machine failure. So if the belt isn't being adjusted, it's going to wear out more frequently or faster, and it's going to cause additional downtime because that belt is more likely to fray and snap and cause that thing to fail. But if the belt tensioner has been adjusted correctly and aligned correctly, the disruption would have likely been avoided. So implementing a PM program is going to help to reduce all of these problems. So a quick argument on the run to failure part: not all equipment or assets need to have a preventive maintenance plan. So we just want to add this caveat here. There are several reasons why we would actually want to have a run to failure maintenance strategy. If these are non-critical assets that have a short lifespan, maybe they're disposable or they don't actually cost that much. So assets that actually would cost you more in labor to maintain them than it would be to just let them fail and replace them. It's just going to be a cheaper and more cost-effective route that way. And then other assets that just have a really high mean time between failure. So if an asset has a mean time between failure that's over years, then the cost of the regularly scheduled maintenance could again exceed the cost of repair at the time of failure. So we just have to understand these different reasons of why we would potentially want to have a run to failure strategy instead of having a preventative maintenance strategy for some of these assets. So one of the other reasons that equipment is going to be breaking down is just the improper usage of the equipment. So the improper usage of the equipment can cause problems that range from operational downtime to a safety accident. And a number of factors can contribute to this. So we can have lack of machine operator training, which kind of goes in hand to hand with lack of documented procedures or standard operating procedures, or just damage during the maintenance process, although this just isn't as common. And so here, operation owner's manuals and standard operating procedures are a key part of your PM program that help you keep that consistent standard for your operators. And lastly, is just having a poor reliability culture. So when it comes to maintenance reliability, it's not always about getting the quickest fix. Rather, it's about having a focus on efficiency and longevity. So reliability, again, it's a long-term game that can produce significantly positive results, but it can take a while. And it requires both buy-in from the whole organization, from the top to the bottom. And using a CMS is often the first step in building a more reliability-centered maintenance organization, because we can start to track why things are failing and have an understanding of what assets are actually failing and how long. And when you're in just this reactive mindset, you won't be able to implement any kind of PM program. And ultimately, that's just going to stop you and your team from effectively identifying the causes of these equipment failures. So building this reliability-centered maintenance organization really requires, two key things. It's a strategic implementation of preventative maintenance and a strategy at place to identify root causes, and earning the buy-in from your entire team, again, from the management to your technicians on the floor that are actually maintaining these machines. And if you lock these things in, you're going to notice a huge reduction in downtime because they indicate a huge shift in your mindset, basically. All right, looks like we have a question next. So what is the single biggest barrier or challenge that you're currently experiencing with maintenance?
Oh, it looks like I launched the wrong one. Sorry, guys. Let me try that again. Here we go. Try it again. What is the single biggest barrier that you're experiencing?
Yeah, so you have frequent or lengthy breakdowns, high maintenance costs, not enough staffing, a lack of maintenance data for reporting, or just that task assignments and scheduling and prioritization for your team.
I'll let it go for another few seconds here. All right, I'm going to cut it off in 3, 2, 1. Awesome. And I'll go ahead and share the results because they're kind of interesting for everybody to see. It looks like we kind of have like close to an even split here of these.
High maintenance cost, not enough staff, lack of maintenance data. Yep, that sounds about right. Okay. All right, want to go into the next one?
Let's do it.
Okay, so basically now we want to identify equipment failure. So we have two things. We have a technique and we have a process. And a technique is a method that you'll use to determine the cause of the failure. So some of these techniques include the 5 whys analysis, fault tree analysis, Pareto chart, and there's plenty more. Unfortunately, there's a lot of information to cover about each one of those. So we can send you some additional resources after the presentation to help you guide you through the process of choosing the right failure technique, analysis technique. And if you're interested in learning more about these different techniques, please let us know in the chat. We're continuing to put on new webinars and we're trying to figure out which topics are most important to you guys. So just again, let us know if that's something you're interested in. And secondly is you need to have a process. So it's a step-by-step repeatable process for your team to identify the cause of the failure. And we're going to get into that step next. So think of yourself like a detective. When it comes to identifying the equipment failures, we have to really think about the process of gathering data, building the timeline of events, and finding the root cause of the failure. And once you've rooted out the cause of the failure, you're going to have the data you need to keep it from happening again in the future. So we have 5 steps for identifying your equipment failures. So first thing we need to do is to define the problem. We need to fully understand why the equipment failed. And in order to do that, we need to gather details about the failure specifically. So first we want to have a problem statement that should contain details about the failure that occurred, what asset it occurred on, what data that we need to be able to, or we need to collect in order to identify the cause. And we want to understand what kind of failure analysis technique that we'll use. And again, this is going to clearly state what happened and how we plan to fix it. Next is actually going out there and collecting the failure data. So all the relevant data has to be collected. We need both quantitative and qualitative data. And this is where you're going to identify all the different possible causal factors of the failure. So again, just a quick review, quantitative data is the data that can be measured with hard numbers. This could maybe be operational units, maybe it's cycle time, age of the piece of equipment, runtime hours, things like that. And this is where the CMMS really comes in handy. So you can be able to track all of the things like age and downtime hours and which parts were used and any of that. And we can talk a little bit more about this in a minute. And next is the qualitative data is on the other hand, this is data that's not measured. It's attained by, interviewing the operators, talking to the technicians. Maybe it's going out there and looking at the machine and understanding, what did it smell like? What did it look like? Was it making any funny noises? And really gathering all that information as well. Next, we want to create a failure timeline. So this is where we want to look at the root causes of a failure are often present before the failure. It's just not always obvious, right? So these root causes can result in a chain reaction that ultimately resulted in the failure of that piece of equipment. And if we study this chain reaction using our data that we've already collected, it can help us identify or create a failure timeline and look and identify what the root cause of that failure was. So In other words, again, we're going to be able to find out when the root causes started and how long of a period of deterioration the equipment endured before it ultimately resulted in a failure. And ideally, this timeline will provide us clarity over the cause and effect relationship between the events, giving us a clearer path to avoid it. So in creating our timeline, you'll likely notice that all the data that you collect in the previous step is relevant to the failure, or maybe is not relevant to the failure, and that's okay. We're just going to use the data that's useful to create our failure timeline and then just discard the rest. So next, this is where we have our technique. So now you have your data and you understand what factors led to the failure, and it's time to analyze to perform the failure analysis. So like I mentioned, there's a number of different failure analysis techniques out there: 5 whys, fishbone, fault tree analysis, Pareto charts, barrier analysis, FMEA. These are all different techniques that you can use to identify the root cause of the failure, and the technique that you choose depends on a wide variety of factors that are unique to your business. And again, you can go ahead and try some of these and figure out which one works best for you guys. But like we mentioned, this is just a whole nother topic in and of itself, and just let us know if you guys want us to dig into this a little bit in a little bit more detail, and we can do that here in the future. But the most important thing to understand here is that regardless of whatever failure analysis technique that you use, this is a step-by-step process that allows you to that provides you with this consistent framework to track the data in order to identify equipment failure causes. And your choice of that failure analysis technique is just one step in this process. So once we've, again, we have that process, we apply the technique, we understand what the root cause of that problem is. Now we're going to look at the results and apply that solution. So in most cases, the failure analysis would result in us wanting to add some new preventative maintenance program in place. In some cases, it may not be. We may understand that, okay, well, the reason that this failed is not something that we could potentially prevent, and we're going to have to have a more run to failure mindset here. But again, we have to understand what's failing, how it's failing, and how frequently it's failing, in order for us to even do anything about it. All right. Let's go on to the next one. And yeah, after that, it's time for a moment of celebration, because at this point in the process, you've cracked the case and given yourself and your team a clear path to preventing these failures in the future. All right, looks like we got another poll question here. So what kind of system are you currently using to manage your maintenance?
All right, that should go up now. Awesome. I'll give it a little bit longer here. All right, and a 3, 2, 1. Awesome. All right, Rick, back to you.
Thanks, Katie. Yeah, so we've done the process. Oops, sorry about that. We've created a structured process to identify and create a root cause analysis to identify the reasons equipment are failing. Now we want to look at some of the key benefits of using a CMMS to prevent these equipment failures and optimize maintenance. So let's go through a couple of these right here. So first is going to be using a CMMS to organize and track your asset data. So the first step to accurately diagnosing failures is to have all your assets organized in one place. So this is going to be a repository of all of your asset data and information, so you can easily understand the equipment you have, how each asset is performing, and all of the assets in Limbo are stored in a searchable hierarchy, so you can do it in whatever configuration that makes most sense to you and your company. Next, we want to start capturing all of this data with work requests and work orders. So data is crucial to identifying the cause of the equipment failure. And one of the ways you can collect data is from the machine operators themselves, especially at the time of failure. So having this data stored directly on an asset is really convenient for your failure analysis, because you're going to look at, again, every single work order or work request that resulted in a failure or any kind of downtime. And there's a really easy way to do that right within Limbo is, you have your QR code on your asset. You can go ahead and scan that with your phone, pops open a work request, and you can enter in those reasons and leave detailed notes about the problem and give some additional clues to the maintenance management team for them to identify some of the failure causes. So, and then once we do that, also within each of these work orders, all of the downtime for this asset is automatically tracked. So you can measure the total amount of downtime hours the asset has accrued over a period of time, how much that's costing you, and what's the mean time to recovery and the mean time to between failures on all of your assets. Next, also within these work orders, we want to create a process to identify the failure. So this is where you're basically going to be taking that analysis technique that you guys decided on and build that directly into your template. So you can build a template where it's an equipment failure template, and it's a root cause analysis template that allows you to predefine the questions that you want your team to answer in order for you to get to the root cause of the problem. So we can collect information like the type of failure, was it a mechanical, electrical, operator error, so on and so forth. If you want to do like the 5 whys technique, you can ask that question. You can ask the why question 5 times in a row. You can also attach different instructional documents like a fishbone diagram and have them re-upload that information back into Limbo. So you can look at and track all of that information and keep it right in the system for your maintenance team to look at. Next, once you have all that data in there, we want to analyze the crucial data for each of our assets. So, now that you've got the data in your system and you've identified the root cause, you can analyze your asset information, develop a strategy, and reduce failures. We may want to be looking at these assets and say, hey, we've had 4 downtime tasks in the past month. Or did they all have the same failure mode? Oh, interesting. They all had a mechanical failure. Now let's look at one of these reasons why, and we can, with that, we can build out a better preventative maintenance program for each of your assets. And that's what we want to do in the next step, right? So we want to implement a preventive maintenance program that helps to reduce these failures. So ideally, you can work this this information into your preventive maintenance plan for your assets to reduce the frequency of failures. So you have an understanding of the vulnerability of your assets, and you can try to proactively address them. So in Limbo, you can create preventive maintenance templates that are customized to your teams and to those specific assets. Again, have very different methodologies or procedures that you guys have in place in order to ensure that the maintenance is being performed the way you want it and at the frequency that you want it. So here we can also easily assign these tasks to team members, schedule the work, and set default priorities so we know what is the most important things to do first. And we also know that not all failures are actually avoidable. So ideally, we can streamline maintenance to a point where preventing failures on our just most critical assets. But other unplanned downtime is likely still to happen due to other things that we covered before, like just the natural wear and tear and the age of the assets. So also reports and dashboards here. Oh yeah, one more thing.
Sorry, Rick.
Yeah. And also in Limbo, there's a number of other reports and dashboards that can help you review the completion of these PMs at a glance to ensure the work is actually getting done on these critical assets. Great, thanks, Katie. Yeah, so next we want to go over a case study. We have a couple here for you to take a look at, but this is Solzer. So now that you've uncovered, or that the process of uncovering equipment failures, we want to share with you a few stories about the customers that have seen success with Limbo. So the first example here is Solzer. They were founded in 1834, and it's a Swiss industrial engineering and manufacturing firm headquartered in Switzerland. They're a global leader in fluid engineering and specialize in pumping, agitation, mixing, separation, and purification technologies. And they have 180 world-class manufacturing facilities and service centers all over the world. So before Limbo, Solzer operated with a paper-based maintenance system. And after years of doing failure maintenance, Solzer consistently ran into the same issues. Their work orders were completed late or not at all. resulting in downtime and delays in production. And it would sometimes be days after the creation of a work order before a repair even began. So as a result, Solzer's work orders had an on-time completion rate of only 49%. So John, their facilities and testing manager at Solzer, said, with Limbo, we finally have a grasp on downtime, problem assets, replacement costs, the total cost of ownership of that asset. And this has allowed us to switch from a run to failure maintenance to preventative maintenance. So within 2 weeks of implementing Limbo, they had uploaded all of their assets and work orders into the system. And after 2 months with Limbo, Solzer's work order completion rate rose by 76%. And so now 92% of their work orders are completed on time. And they've been able to increase their overall productivity by 23% or 26%. And now we're going to also watch one more video, or we're going to watch a video of another customer, Bentech, who's seeing similar results with Limbo.
30% time savings of my team that we would have had to spend trying to track down the cause of problems. My name is Matt Olson. I'm the facility and reliability manager here at Bentech. We're a manufacturing facility here in San Jose. I've been using Limbo here for managing all aspects of the facility and machine reliability. Previously to using Limbo in a facility with no system, no CMMS, it would involve a lot of walking around, talking to equipment operators. Things would be broken. I would walk out on the shop floor and I would see equipment broken and operators standing around the equipment, and communication was done by email. To me, Limbo stood out for a couple of reasons. There's the fact that it was so easy to implement, basically got all the important parts of it were all done in one day. Another thing I love about Limbo is that in the manage work screen, it shows all open work orders. You can see what's overdue. You can see how overdue it is, who it's assigned to, and then it's real easy to send out reminders to the team. I also have QR codes on all of our machines so that the operators can submit work orders anytime they have a problem. This is some of the brand new machines where first thing I did when we got these machines is I put the QR codes on them. These are our injection molding machines. Same thing, they've all got QR codes for submitting a work request. To me, that's really helpful because we don't want the operators to try to fix the machines themselves. So the easier it is for them to submit a work order, the more likely that they'll actually use the system. Over here are all the air tools that we calibrate. We do torque testing on these every 2 weeks. So I've got to keep track of all the torque settings for all the different tools. The customer support with Limbo is amazing. I've been really impressed with how easy it is to get a hold of somebody. The response is right away. Everybody who uses Limbo has been super impressed. As an example, this specific person who had all their work orders completed on time, when I saw that, I called him in and I showed it to him. I said, hey, you're doing a good job. Take a look at this. Everything you're doing is on time. I just wanted you to know that we see this. I'm really proud of what I'm doing and the efficiency and the way I do it. I really feel like it makes a big impact. Everybody who uses Limbo has been super impressed. When somebody submits a work order, their response is right away. Right from the beginning, I wanted everybody to know that Limbo worked. The more people trusted it, the more they would use it. So when somebody submits a work order, it's like they turn around and there's already somebody there to help them.
Awesome. Okay, now we'll do some Q&A. So folks that are on the webinar, if you have questions for Rick, go ahead and drop them in that Q&A that you see on your screen, and we'll get some of those answered for you. Let me open this up here. Okay. I've got one question here for you to start, Rick. What would you do to promote reliability culture?
Yeah, I think the first thing for me is, I'd want to look at the data and understand the environment that we're operating in. So if I'm at a new organization and, I want to look at what is the maintenance backlog? Where are our assets failing and how frequently are they failing? We can start to get this information and understanding the impact of that, right? If we are starting to look at and say, man, the impact of these failures are causing lots of production loss and downtime, or they're inconveniencing, schools are basically the learning process at a school, right? We can understand the actual impact of these downtime events, and we can look at, okay, well, how can we start to we understand the impact. We can plead to the emotions of more of that senior management and say, hey, look at this. We're causing there's all these impacts, right? How can we prevent this? We need to shift our entire mindset from fix it when it breaks to prevent it, right? So we just don't have to incur these types of or have these types of incidences even happen in the future. So to me, it's really first trying to look at the data, understand, the frequency that these things are happening, and look at the impact of that to bring that to the team and try to get people to have ownership of the situation at hand. Because if you don't have ownership of the assets, you don't have ownership of the process, then you're not going to feel tied to really trying to prevent these things. Again, if you're at let's say a university, and your mission is to ensure or create and foster a creative learning environment. Well, even in the maintenance management group, you can do that by ensuring that the HVAC systems are working correctly, the lights are on, the doors work, there's no broken furniture. There are still plenty of things that you can do in the maintenance management side of the department that are tied to that mission. So really it's about, having that level of ownership across the organization as well.
Awesome. Another question, not unrelated, but would love to hear your thoughts, Rick. How would you motivate your techs to report work orders, parts used, and time in the CMMS?
Yeah, I think, again, part of that goes to that ownership process, right? You got to make sure that they feel bought in and they understand the reason that they're doing these things. Because in some environments, it can feel like there's just a lot more oversight and micromanagement, which doesn't really get the techs to do what you want them to do. And it takes a lot of soft skills, a lot of people management to understand, what they're motivated by, how to bring alignment across the organization from each one of your technicians, and how to tie that to the mission of your company. Because once you see that, you can really look at how do you empower people to be the best that they can be by getting you guys the information that you need. So if everybody's tied to that mission, like in the previous example of, fostering a creative learning environment, well, the technicians know that, hey, when there's something that breaks in a classroom, we need to understand what broke, how it broke, what it cost us, how much time it took, so we can look at getting the additional resources that we need as an organization to promote and foster that creative learning environment. So yeah, it's definitely a challenging aspect, and there's always going to be people that push back, and there's always going to be people that don't necessarily want to add all that information. But once you get a system in place, and there's a system that is easy to use, so not like some of these other older legacy ERP systems or other legacy maintenance management systems that take you 15, 20 plus clicks in order to figure out how to add a part, how to add time, and how to show that you're completing a task. It just creates a lot of frustration, and technicians don't necessarily want to spend the time doing that because they're paid to fix things, not enter data into a system. So really having a streamlined maintenance management system that's simple and easy to use is another part of that, because then it turns into just another tool. It's something that is a joy for them to use, and also that they can use to celebrate the work that they've done, right?
Totally. Awesome. Again, similar question, but kind of the different side of the same coin. How do you get buy-in from management for something like CMMS? We can kind of understand that a CMMS is a big part of identifying these equipment failures. How do you go up the chain?
Yeah, I think, when you look at a maintenance manager and you see this maybe piles of paper and a complete disorganized process. Maybe you're just drowning in reactive maintenance and there's a new fire every single day, and maybe there's multiple fires. You kind of get to that point where you look at it all and you look around and you go, this is just not sustainable. It's not a way for us to actually to operate effectively. So again, this is another one where you really have to show the benefit, or really, let's say, paint a very clear picture of the problems that your team is addressing or you're facing, whether that be, again, lots of machines that are breaking down, a lack of staff, a lack of having the parts that you need on time to be able to fix the things that are breaking, and show, okay, well, here are some of the things that CMSs are actually used for. It is used for solving these very problems. It's used for organizing all of your information and ensuring that we're capturing that from all the different requesters out there. It's from getting all of your assets in place so you can understand what you actually have to maintain and what's the most important things for you to maintain. It's then, going from there and really looking at, okay, well, what of all of our tasks? How do we actually, what do we actually need to do? How do we prioritize this work? What kind of staffing do we have in place? And so kind of, again, building that case. And one of the big ways to do that is to look at, what's really identify those core problems, come up with some reasons or how the CMMS will actually be able to solve these problems, and then look at the return on investment for your firm, and then bring that to the management in order to show that there is a ton of value here for us.
Awesome. Another question. How would you implement Limbo at a small scale plant? And it's kind of a twofer. And how can you collect data on an installation error?
Yeah, collect data on an installation error. Maybe I'm not fully understanding what they mean by that. But implementing Limbo is really simple. The biggest thing for you at the very beginning is getting a collection of your assets, right? So if you don't have any list right now, it's the first things first is to actually start to create that list. And you can do that in a spreadsheet, listing out the name of the asset, the ID of the asset if you have a unique one, make, model, any other important information, whether that be, amperage, voltage, serial number, so on and so forth, and really start to build out what your asset list is. And once you do that, it's going to be really easy. It's just a one-click import right into Limbo to be able to get all that data in there. And once you import the data, then now you can actually start sharing that work request portal link out with your team and add your team members in there and start creating task or preventive maintenance schedules for that. So it's really simple, and definitely would recommend talking to some of our account executives to be able to show you exactly how that works.
Awesome. I got a couple questions here about SAP. Can you talk about maybe how Limbo compares and how it also integrates with SAP?
Yeah, so there's a number of other customers that we have that basically integrate with SAP ERP system in order to replace their SAP PM module. Again, as I'm sure you folks know, that the SAP PM module is not very user-friendly. Yes, it is integrated into the ERP system, but it just, there's lots of clicks. It's very menu heavy, and it's just not really as intuitive for the team, right? And again, so there's plenty of ways to integrate with SAP, whether that be for, reporting on all the parts that were used or the purchasing that was done, and be able to link those two systems together. So you still have a single system of record in your ERP system. And the same goes with any other kind of ERP like Microsoft Dynamics or NetSuite.
Awesome. I've got one more question here. We'll do one more question and then we'll close it up. Last question. How can we engage an asset performance management or maintenance in firm?
In firm.
which I think if I'm using context clues here, like, do you mean like at your company? That's kind of what I'm thinking. And that's how I'm interpreting that. Yeah.
Mhm. At your company. Yeah. How to engage in asset performance management or maintenance. Yeah, I mean, like the first thing, it's kind of a lot of what we talked about, right? At first you have to understand what your assets are, when they're failing, how often they're failing, what is that actually costing you, get a better understanding of the performance of your assets, right? And then we can look at ways, once we understand the performance of our assets, we can understand what's the actual financial impact to our business. And if we want to, once we understand that financial impact of the business, we can look at, okay, well, if we implement a new process for us to be able to increase our uptime, what is that going to look like? And we can see our return on investment there. So really it's that first phase. I mean, you just got to get in there and start tracking your assets, understanding, what is going down, how often it's going down, and what it's really costing your company.
Awesome. Thank you all for your questions. If you have more questions, we're close on time here, but as you have more questions, like, please feel free to like email them over to us. People are reading the emails, so someone will see them, and we'd love to help out. So we've got another webinar coming up next week. And this is a live demo. So mark your calendars, next Thursday, July 20th. At 9:30 a.m. Pacific time, 12:30 p.m. Eastern time. And we're going to cover like how you can set up your entire PM program inside of Limbo. So we'll send an email after this that will include a recording of this webinar, as well as a way for you to sign up for this live demo if you're interested, or if you happen to have a device handy, you can scan that QR code real quick before I change the slide, and jump onto that page if you're interested in signing up for that. And then otherwise, if you're ready to talk with a product specialist about how Limbo can help, go to this page here, limbocmms.com/demo-request, and we can hook you up there. Otherwise, you all are an invaluable part of our community, and we're excited and happy to be putting these things on. So we're happy to see you around. Thank you all so much for being here. Rick, do you have any final words?
Oh, thank you very much. I really appreciate everybody coming today and listening to me talk. So really do appreciate that, and hope you all have a wonderful day.
Awesome.